types. Right? So we have seen.
Okay.
Yeah.
Are you recording the video?
Yeah, I've started recording. Yeah.
Okay, it's good.
Okay, not a problem. So, do you have any doubts from yesterday's class? Have you tried anything?
Yeah.
Yeah. Please tell me what is that. Let's clear that.
So I just want to I need a quick review of the class and method. Just a quick.
Okay, fine.
And,
sure.
Yeah. Yeah, I just was playing around with this program. It was okay.
Okay, fine. So a class is nothing but a set of variables and methods, right? Where you can have any number of variables defined. So variable is nothing but we'll get to know now what is a variable under data types, right? We'll understand that, fine. And we have something called methods. So methods are like containers of logic, different containers of logic. You can write any number of methods inside a class, fine. So among all, main is a one method which is the declaration should be same, public static void main, which is the actual trigger point of any application. If you don't have main in any of your application will not work, fine. And we can write any number of methods, for writing different logic. So I have written here something like print sum, where I have taken a variables again inside this method. I have just a simple math here and I have printed it. It's like cout, like I have just done println, and sum is I have just printed my z over here. Fine. You'll understand why I have done this once we are done with the wrapper classes and data types, right? Not a problem. So these are methods and these are something called variables. I see. We are saying variable, right? We are saying the word variable, which means it can vary, right? It can vary among your methods, any of the method or across the methods or inside the main, anywhere it can vary. So that's why they are called as variables, which can vary, right? And methods are something, right? Or functions are something which can function, right? Where you have something called logic, which makes your application function in a way where you have written the logic. Here I have just written to do some sum and print, so it function in that way, right? Those are nothing but your functions, and these are nothing but your variables. You can have only variables and functions in a class, nothing else. Whatever big program you are writing, it will come under either an attribute or a variable or a method or a behavior, right? So that's a variable and that was a method, right? Methods. Fine. Shiva, any more doubts in here, like why we have? And one more thing is, you can call, we will be seeing what are the different types of methods we have. Types in the sense, there is no different type as such, but how many ways you can write a method and how many ways it can be called, right? In a same class, we will be seeing that. Fine. Once you understand data types and few topics, then I'll get back here and I'll let you, once we complete at least data types, we'll get back to the same program again, right? And let me show you like how different way we can write a method, right? I won't say types, I will say how different ways we can write a method. Fine. Fine. So any more clarifications you need here, or let's move on to data types?
What do you need? What do you mean by data types? Yeah.
So we'll start data type now.
Fine. What do you mean by data type?
Yeah, data type. Data type is nothing but these are holders of data. So these are nothing but holders of data. Holders of data in the sense, in real time, let us say you have a bank account, okay? So you'll go to bank and you'll deposit some money, let us say, right? So what you'll do, let us say you have saved some $10,000 with the banker. So what banker will do? Banker will go to application, right? Application, and he will update your 10,000 to your account, right? Right. Yeah. Or let us take a simple example where you have a Facebook. You have commented something. Hi, how are you? Just you commented something and you just entered it, right? So what happens? when you enter this in your text box, it will, and when you press enter, it will go to the actual buffer field, right? So whatever you are providing is nothing but a data. This is data, and inside application should catch your data and save it something. So that something is nothing but a data. Right? You can, data can be of anything, right? Data can be your 10,000 is a data, right? Which is a number. Your 23.567 is data, which is something like in decimal values, right? You can, dollar can be a data, right? Or you have some special characters is a data, right? Your numbers is a data, your small characters is a data, your caps is a data, your sentence like how are you is a data, right? So all these things are nothing but data, and we use some specific types. We have Java have classified all this data into some certain classifications, some 4 classifications to hold any number of any kind of data. So that is nothing but your data type. Data, which is nothing but data type, and they are classified into some types, right? And they are nothing but data types, and we'll be seeing what are the different data types we have in Java. Fine?
Okay.
Yeah. So let's see what are the data types in Java. We have four classifications of right data types. So they are, first one is integer, or let me take it as character. First one is character. Let us see what is a character. Like under character we have, so character is nothing but, one character. When you write something, you know what is a character, right? When you write G is a character, 6 is a character, right? In that way, let me write these things in next tab, so that will be good, right? So those are nothing but characters. Anything G, like some special character or number, anything is a character. Or if you try to write some Chinese word or some Telugu word or some Hindi word, everything is a character, right? Yeah. So now they are classified. They are classified under character subclass. So whatever I am gonna show here, 4 different types are nothing but classes in Java, right? So classes in the sense, whatever we have written here in this way, they have written some more classes for character, like how differently we can use them. Fine. So under character we have data type called char. We have seen int, right? We have seen int, count is equal to 0. In the same way, we have something called char. Char is nothing but, I can write it this way. Char, you can see purple here, right? Char. Let me say my character. My character is equal to, I can say something called D here. So your character is used to save one character. Fine. What's happening? Fine. Your character is used to save one character. It can be anything. It can be a data type or special character or a number. Anything it will accept. So this is the declaration of a character. Fine. So that is nothing but a char, which is under character. This is the first classification we have. Fine. And now this is the first classification. Now, and under that we have something called character. Let's move on. So we have second character, which is, we'll get back to character again. We have some more things to learn in character. We have something called integer, right? So integer is provided, this class is provided to save all the numbers, or I can say all the non-decimal numbers. Let me take 23 is a number. 23.456 is also a number, right? But in this number class, you can store only only the non-indexed values, which is non-decimal values only. So among this, if you just go and assign this, only 23 will be saved, and apart from that, everything will be cleared up, right? So this data type, so this is a data type where only numbers can be saved. So under this we have something called int. We have seen int, which is nothing but your int here, right? Where we have used something called a number to save. This is a variable. We have something called long. We have long. we have some byte, we have short. Let me explain you why we have these many data types or end data types under a main data type called integer or a main class called integer. Anyways, we'll be using the end ones itself, we'll not be using the parent classes, right? So int, right? So int here, what it does, like I said int, let me take I is equal to 10, right? So these are we declare. So in the declaration part, so this is a data type, right? And this is the variable. We set variables, right? So the variable is nothing but this I. I is a name of a variable. What I'm doing, I'm assigning some value called 10. Yeah, 10 to I, right? Which means my I is of type int, right? And the value is 10, right? In the same way, let me write some long L is equal to something big, which means my L is nothing but a variable of type of data type long, and the value is this. In the same way, we have something called byte. Byte, let me take p is equal to some 12. In the same way, short. All are used to save some number, right? All are used some number like int, long, byte. Same in the here. What we have done, we have wrote something called s is a variable, right? Of type short, and the value is 234. Now for saving same kind of data, why do we need different variables? You may get that doubt, right? Because while saving character, we got only one. But here, why do we have so many? Now, let us see why do we have so many in that. So when we come to character, right? Character size in Java is of 2 bytes, right? This is very important. If you know C++, right? In C++, it was only 1 byte. So what is a byte? Which means character can save a character which can be of 2 bytes. Like it can go till 2 bytes of data. Whenever you write something, right? If I say whenever you write something like 5, and if you want to save in character, let's say it's char c is equal to some 5, right? Some memory will be allocated for this, because let us say if you have a Microsoft Word, as your Microsoft Word grows typing, like you are typing some paragraph, right? Let us say you have done with some 100 lines, right? And you are just saving it up. What happens? Your Microsoft Word will take some space in your hard disk, right? As your Microsoft Word grows, right? As your Microsoft Word grows, what happens? Your size of your file will grow. Am I right? Which means as you are typing more characters, your size is growing. Which means each and every data is nothing but is taking some memory to save. Fine. So that is nothing but your memory. So here you can save your character till 2 bytes. Now, what is a byte? You have any idea on bytes, Shiva, or you want me to explain?
I did byte, but I don't remember.
Okay, byte is, so a single byte is nothing but 8 bits. 1 byte is equal to something called 8 bits. Bits is...
Oh, is that zeros and ones? Something
exactly, like yeah, zeros and ones, yeah. So zeros and ones, which is like, when I say my character is 2 bytes, which means 16 bits, and this char 5 will be converted into zeros and ones and will be saved in bit manner, which is like this.
Oh, yeah.
Yeah, let me just show it up. The arrangement of bits will be in this way. Like, I'll just go here. Color. So arrangement of bits will be in this way, right? We have, I'm just talking about 1 byte, right, is equal to 8 bits, right? So which is like this: 3, 4, 6, 3, 4, 5, 6, 7, 8. Fine. So this is nothing but your memory stack, right? And you have something called 0, 1, 2, 3, 4, 5, 6, 7, 8 bits, right? And your zeros and ones will be saved here. Fine. So here, whenever I say 2 bytes, which means 2 bytes is nothing but 16 bits, right? Which means 2 bit stack, right? Your character, so here your character will be converted into bits and will be saved in something called C. So this C will be referencing to 2 byte stack where your 5 will be saved. Fine. So that is nothing but memory, right? Which means I said character is 2 bytes. So your character can hold up to 16 bits of memory. If your character is going beyond that, your this data type cannot hold that. Fine. So that is nothing but memory here. And in world actually, if you take some characters like some language characters like some Chinese, Japanese, Hindi, or any character, so they are called as Unicodes in Java. Unicodes, not in Java. In any language, all the characters are also called as Unicodes. Unicodes in a sense, they are special characters where if you want to type a Chinese character using your keyboard, you have to use combination of key, right? Have you ever seen if you want to type in some other language, you have to go for some combination of your keys, right? It happens actually, right? So combination of keys in the sense you are increasing your byte size, right? So that's how in world whatever Unicode or character is there, it won't go beyond 2 bytes. So that's why in Java the size of character is nothing but 2 bytes. Fine. Now I hope you understood what is 2 bytes, why the size we need. We need size in order to save or store some data in it. Fine. In the same way, when you come to integer, under int, let me just keep it in this way. Let me just keep it in this way so that you understand. Now, a byte is nothing. The size of byte is 1 byte. It's the same byte, right? And short takes some 2 bytes. Long takes 4 bytes. And int take 4 bytes and long takes some 8 bytes of memory. Now, can you see the difference now? So why we have so many data types under integers? Let us say you are playing with you are writing an application where you want to save numbers. Let me say, right? Now we know that if you are going for a number, it won't go, let us say, some in between some range which is 1 byte range, right? At that time, if you are going to use this data type, what will happen? You know that you are going to store only data types or numbers which will take at least 1 byte. That's it. But if you use something called long here, you are unnecessarily wasting 7 bytes of memory. Am I right? You are getting this? Yeah. If you get confused anytime, just buzz me up so that as you understood this. That's why I am explaining this part, right? Which means, let us take an example of banking, right? Now, in banking, your account ID will not go beyond 4 bytes, let us say. Your account number, let us say you have some account number in this way, right? Some account number where this account number will not go some 4 bytes, let us say. So that's why they'll take data type int, like let me say something like, let me just then show it. Like what I'll say some int account, right? Account ID is equal to, I just said some value, right? Some value, fine. So here what is happening is my account ID, so banker guy is using this account ID, right? Some account ID to save his account ID. Now why he is not supposed to use long is, he knows that each and every account ID will not go beyond 4 bytes, right? And if in the same place of int, if he tries to use long, what happens? See how many accounts will be there in bank? It will be in millions, right? So many people will open their own accounts, and so many people can open multiple accounts, right? As a joint account or as savings and current account, so many things. Now, if you in place of int, if you try to use long, what happens? How many bytes will be wasted per account? 4 bytes will be wasted.
It's just
right.
So is it just for like saving some memory? their system.
Yes, right. Yeah, because
right.
Yeah, saving some memory. Perfect. Saving some memory in database, let us say, right? Where instead of this, you are using this, which means when you have some something like 1 million accounts, right? Which means all the whole memory of account IDs will be 4 million bytes. Am I right? 4 million bytes. So if you use long, what happens? It will be doubled, where you don't need that much of memory to be saved, right? Because memory is costly, right? So that's why you have to choose your integer based on your choice or based on your requirement. So basically, go for something for like int. It will be served even the lowest ones or sometimes even the higher ones, right? So the optimized one is used to use int, right? So it can hold some integers of these. Fine.
I have a question.
Yeah, sure.
Okay, do you know when to use the int and when to use the long? Right?
Yeah.
Because is it like you have to do the calculation like the
No, not at all. No, you don't have to.
How do you know?
Yeah.
How do you know what to use? Like if it's say it's two long numbers, right?
Yeah.
So you don't know. So how do you classify?
Yeah.
How do you do it?
Okay, classification is in this way, Shiva. So let us take again the example of something like price calculator.
The bank account is good.
Okay, bank account. Let me take the bank account, right? So there the problem is, they want to maintain some number of integers for that. Let us say, so recently, if you have if you know that HDFC Bank, they have increased their account number to 3 digits. Initially, it was some 10 digits. They have increased to 3 more digits. Why? In order to accommodate some more account IDs, right? In the same way, see, let me show you something here. Let me take again, we have written something called int and all, right? Int, right? We have taken these data types, right? Let me just go to byte and so let me go for a byte here, right now. So let me give some bigger number here. See what happens. Can you see this? What happens?
Oh, the error.
Yeah, error. Type mismatch cannot convert from int to byte because it knows that whatever number you are giving is an int because you are giving a bigger number. Right? So here, if you decrease it to some level again, it will take. Now here again, let's go back and see. See, again it says something. Let me read one. Right now, see, it is again giving some error. Save it up. Right now. Now can you see here, which means a short can accommodate up to some level of numbers. Again, int. Let me take up this big number. Again it says, see, out of range. Right? Again decrease some values. Right? I mean, this is nothing but your number of digits it wants. You understood now? The same way long can go for some extent, but again see, it has got some again some limit here which cannot be accommodated, right? It can have something like this, you can have some less of this. So in this way, like you can save different values. Now what purpose you want to serve? Let us say you know that, see, initially you use something called int for, let us say some number of in the sense some count of some integer value, and you know that in future it can grow till some bigger number, right? So at that time you have to go for higher data type, right? Now let us say you have a program, right? You have a program here which is in a class you have a method here, right? And this method always does that, it will add 2 numbers and 2 numbers should be less than 100, let us say. So instead of, I know that this number will be always less than 100, right? So why should I use int here? I can also use something called byte. Am I right?
Yeah.
Because byte can accommodate something like the value less than 100, and you know that.
Oh, okay.
Right? So at that time you will be using something called byte, right? And I know that if you sum up 2 bytes, 100 and 100, you won't be accommodated in byte, but you can accommodate in short, let us say. Short is 2 bytes, right? What is happening here? Okay, fine. Your byte is, you have to convert it in this. Let me take something called higher value, or you can take some int again. I'll tell
So
you
why
what
is it not taking it?
exactly. I'll tell you why it is not taking, because you have to do something called typecasting here. Cast. Can you see this? Cannot convert from int to short. I'll show you why we are doing, why we have this. Okay, so that you'll understand. Because typecasting will come once you understand data types and some more concepts. I'll tell you that. No problem, right? So as of now, take some other variable where you wanna say this. You know that this won't go beyond 100, so that's why we are taking something called byte. If you know that this can go beyond 100 and some value which can accommodate a short, go for that.
Sure.
Right? So that is how we have to decide. And for basic applications, you need only int. It won't go anyways. It won't go more than 4 byte of size. Not to worry. Fine. So that's how we have to decide which data type to use. Any doubts in here again? Because anyways, don't worry about much of this, because the thing is, let us say tomorrow your integer here has to expand more. Just at one place replace this with long. That's it. Your whole, that's why we say variable should be written at one place, right, where you can use I in any manner, right? So that's why if you have int here, right, tomorrow let us say it is growing more than int, just say this data type is long. Now variable will be I itself, it can accommodate till long. Fine. Now have you got more confusions here, like where to use and why?
No. Yeah? Everything is clear except one thing.
Yeah.
I have a question regarding
Sure.
the my character, right? You put equals to 4. What does the 4 stand for?
4 here is the 4 is a character which is of type number. That's it. But here it doesn't. It is not actually a number. It's a character. Character in the sense one word. 4 is a word here. That's it. Like R, we have T, right? T is a word. In the same way, here 4 is a word. That's it. But if I replace this quotes here, then it is a number. You got it?
Okay.
You got it. My character cannot. Yeah. Why do we need?
Why do you need the character? What is the use of character?
Like, let us say I want to write some. See, we have written something. So let us take this one. Pen, P-E-N, right? So this is a combination of characters. P is a character, E is a character, and N is a character. You remember this? P-E-N.
Okay.
I said P-E-N is a string, right? String is nothing but a array. Combination of characters is nothing but a string. So why do we need character? We need character in order to formulate some words or some sentence. Let me take as hi, how are you? Right here, your H is a character, I is a character, which means string is a combination of characters, right? Or array of characters. So here, if you don't have something called character, you will not be able to create something called string. Fine. Can you see this? String is a array of characters where I'm just saying A, B, C, right? 3, and I'm formatting something called ABC.
Okay.
Right? So if you don't have characters in place, right? You cannot use each character in a string. So that's why we have a character. Right? And you use characters mostly to define something like some if you don't want to have a big strings, just take one character and just say some H, which means H represents something, let us say. So I'll be taking only one character. But if I want to add some more to this, I cannot take this. Can you see this? It says some error, invalid character constant, which means I have to remove one. If you want to go for multiple, you have to go for a string. Again, string and character are related again. String is nothing but a combination of characters, which is hi, H is a character, I is a character, space is a character, how, HOW is a character, again space is a character, R is a character, U is a character. Each and everything here is a character. Fine. Again, your question mark is a character again. So we are just combining all the characters to form a string.
So how many characters can you accommodate on when you take a string?
There is no limit for string. You can accommodate any.
Okay.
So that's why it is not called under any data type. because it's an infinite size. You can accommodate any number of strings here, any number of characters here. Fine. It all depends. It all depends on how much memory you have in your hard disk to save this application. As big as your hard disk is, yeah.
But one more question is, you declare the character here, right? So it's just like you're telling the computer that you're trying to use some character.
Exactly.
Right?
Yeah.
That's it.
Yeah, that's it. Yeah. Perfect.
And it doesn't carry any value, right?
It does. Yeah. It doesn't. Value doesn't matter at all here when we are in calculation.
Yeah. That doesn't matter. That's what I was supposed.
Perfect. Yeah.
It doesn't matter. It's just like you are just telling the computer that you want to use some characters, right?
Correct.
But you did not use it before. Why is that? Like,
I'm sorry, you did not?
Is this like a program that we are doing right now, or it's just like a random program?
No. I just took this to show you these things. But anyways,
just to show me, right?
Exactly. Yeah. I'm not writing anything here. We'll be just rubbing it up. I just wanted to show here.
Explanation.
Yeah, just an explanation, nothing else. Right? Maybe I can retain all these things here to make it as variables, right? I can also make them all variables. I can use them, right? There is no harm in it, right? I can say all these are variables. I'm going to write some programs here. I can say that, right? Because class is nothing but set of variables and some methods. So I said whatever I have written is nothing but a variable, right? So anyways, as of now, I'm just making you understand what is a variable, how to declare a variable, and what exactly data is, and what is a variable name here, right? And what is a data type.
Yep.
Right? I can also retain them. There is no harm in it. Fine.
Yeah. Okay. Perfect.
Yeah, because you can write any number of variables in your class. So that is nothing but your integer. Integer is nothing but it can save all the integral part of your numbers. Integral part is nothing but, so if you are writing any decimal, you have two things. I say this one. So this is nothing but your integral part. Fine. And even if you write to 24, what is the actual app value of 24? It is nothing but 24.0.
2.400.
Fine, 24.0. Yeah. Which is again a decimal value of 24, which means it can save only integral value, right? So that's how we have so many data types, because we based on your requirement you can choose any of one of them. Fine. For real-time programming you can just use int, because it can accommodate all the measure of your data types. Fine. So that is your integer. Now let's go back to next data type, which is third one, which is floating. Again, the whole floating class, under floating class, whatever you have is to save both integral values and decimals. You can save anything in it, right? And again, floating, we have something called float here and double. So these are the two data types we have. Float will have 4 bytes of memory, and double have got 8 bytes. So we have only two data types here, which is float and double. Fine. We don't have 4. We have only two data, which is float and double. So how to declare this float and double? Again, let's go back here, right? Float. It's a straightforward data type, float, right? Let me take f is equal to, I'll just say 0.2 some number, right? For representing float, you have to use a word called f here. So this is the only data type where we have to append some character called f, which means you are representing that this decimal is of type float, f. Fine. Why we have to represent this is, when I say double d is equal to some value. Sorry, 4, 5, 6, 7, some value. Right, semicolon there. Right here.
And you don't put a d there?
No. Only for float. Only one data type here, which shows f. Yeah. If you remove this, and if you are trying to accommodate f, it won't. Yeah, it will say mismatch. Actually, by default, any decimal will be considered. Any of the decimal value will be considered as double. Actually, that's why if you want to make it as a float, you have to make it as f. So why do we need to make it float? Because if you don't want to go beyond, if you know that your value will not go beyond 4 bytes, why unnecessarily using double, right? So that's why we go for float. For representing it as a float, you have to make it as F character, and this is the only data type where you use character after your number, fine? No one else. So double is something like, if any decimal value is nothing but a double. So this is the declaration of double. So those are the two different floating values you have. Again, you can also save your float in this way, like, or double in this way. I just say double D is equal to, I can say 123. Yeah, we can save it up. Not a problem. Because internally it will be saved in 123.0 format. Fine. Any doubts here?
No.
Okay, fine. So now, so you want to see how it prints. Let me just take this Z as double. Let me just show you how it works. Let me just remove this up. Double D, or let me take D is equal to 123, I said. So I said it will be printing. Let us see what actually it prints. Value, I'll just say value. I'll just say I have to convert this. I'll be explaining this why you have to do this. Not to worry. String of some. I'll take something. Oh, sorry, it was double. Fine, let me turn this up, because this is a method where I've defined one variable, right? I'm doing some operation like printing, and I'm calling this method from this method, which is a main method. Again, this main is nothing but a trigger point, right? So now let me turn this up. Can you see this?
Yes.
Yeah. What we gave is 123, but it's saved inside as a 120.0. This is nothing but a decimal value of 123, right? So that's how it works. Fine. So yeah. So again, you may be getting some doubt that if there is a F, what happens, right? Let me print one more value here. Sys out, right? Let me just directly print, which is nothing but float dot toString of F. Let me take the same F here, because I have declared my variable here. I can take that variable and print here, right? Right.
Yeah.
There's a problem here. Okay, not a problem. We'll be understanding what is static is. And let me run this up. Can you see? Your F will never get printed. The only value will get printed, which is nothing but 2, 3, 4, 5, right? Your F is not a data type. You are just representing F to make sure that your decimal is a float. But when you take and print that, it will be printing only value. Fine? This is how it works.
Okay.
So that is nothing but your...
Just a quick question.
Yeah, sure.
Can you go back to the program screen?
Yeah, I'm
okay, so can you see my mouse, right? See my mouse moving?
No, you can just click on something.
No?
Maybe you can... Yeah, now I can see. Yeah.
Okay. So now these are called these are what you actually do with a variable, right?
Yeah, you can select them, because again it went off. You can select. So you're talking about these?
Yeah.
Yeah. Yes. These are nothing but variables, right?
Variable. Okay.
Yeah.
This, the public stat void. This is a method. These things are methods, right?
These ones, yeah, methods, yeah.
And the system.out, is that called an operation?
Exactly. This is an operation or a logic you're writing. Yeah.
Operation and method, and you do the variable.
Exactly. Perfect.
Oh, okay, perfect. I got you.
Right. Cool.
Yeah.
Yeah. So fine over there. So again, you can just print any of these using these values. I hope you understood now, right? You can do any sort of operation now. Perfect. Now. So that is nothing but floating, and you have two different floats. You can use either of them. I hope now you are getting a feel of data type, right? What is a data type? Fine?
Yes.
Cool. That's what I want. Yeah. Let's go back and see. We have one last data type, which is nothing but Boolean. I hope you know the Boolean. If you know some part of C, Boolean. No. Boolean.
Actually, no, I don't.
No issues. Boolean is it is a data type which can say only two things, either true or false. it have only two values, either true or false, which is nothing but you can use this Boolean data type for flag type. Let me just give one basic thing here. Let me define some bool. You can see here Boolean, right? Let me take some b or bln, some bln variable is equal to, can you see, if I type 3, it will give me true. Fine. So every time whenever I am getting this window, it means I'm pressing some control space. Can you see here? Press control space to show template proposals, right? So that's how I'm just pressing, and it will give you everything. Just select on true. Here in Boolean, you can either select a true or a false. It won't allow anything else. Let me give some string here. Something like, there's some word. This is. Can you see? It won't allow anything else apart from Boolean, which is nothing but you can give only true or false, which is And now Boolean is of 1 bit. This is not even a byte. It will take only 1 bit, which means it can store a 0 or a 1. 0 means false, 1 means true. If you mention it as true, which means inside to stack it will say 1. If you make it false, right? If you make it false, inside a Java operation, it will save it as a 0. And whenever you use bln, there you will be getting this false or true. Fine.
Okay. Yeah, I got you.
Yeah. Okay. Fine. So this is same as the bool you have in C. Bool where you can save something called zeros and ones. In C and C++, we never had something called true or false. There we used to save something called 0 and 1. 0 is nothing but false and 1 is nothing but true. So again they have used the same thing internally to this. Fine.
Okay.
So that is a data type. We have one thing which is Boolean, which is 1 bit. So we have only one data type here, which is Boolean. So that's it. We have these number of data types we have. Let me remove this. So now you can see we have 4 data types, which is character, integer, floating and Boolean, right? Under character we have only one, which is char, of 2 bytes, and you can save any Unicode in it, right? And you have something called integer, where we have 4 different types of integers, which are nothing but your data types. You have floating, float and double of 4 and 8 bytes respectively, and you have something called Boolean. Under Boolean you have something called Boolean data type, which is 1. It's a Boolean data type is nothing but it's a small b, right? You can see all those things in here again. So I've written Boolean class B, right, capital. You can also see that B. Can you see this? Boolean.
Yeah.
So under this Boolean we have something called bool. In the same way you can see integer, capital integer. Can you see this? All these classes are again mentioned here, not a problem. You can see something called float. Float. I mean it's not floating, it's float. Anyways, like we call we basically call it as a floating numbers, right? That's why I just wrote floating. We have something called float, right? So in that way you get all these data types, right? So these are nothing but your data types here. So any more doubts in here?
No, perfect.
Fine. So these are data types, and this is how we actually declare data types, right? How differently. The only way of declaring float is again the same as decimal value, but you just have to append something called f in order to make sure whatever you are writing is of type float and f. Fine.
Yeah.
So this is a concept of data type which we have, and how to use them is now. Anyways, now I think you will be slowly you will be understanding as our concept grows. You will be understanding much about variables and methods. I'm sure, because today you got something like how actually we got a basic difference that we have all operations inside methods, all variables outside, right? So in that way you will be getting, again, if you can see inside a method I have an operation, also I have declared some variable. Fine. So these again nothing but your variable. Fine. So that is possible.
Yeah.
So this is how we actually work with data types, and data types can be used inside your methods for different operations. Right, right. So again I said you can write any number of methods, right? Let me write one more method, public static void, right? Void, let me say add numbers, add ints, or add numbers. Let me take, right? And here what I want to do is So we have two longs here, right? Which is long I, long L, right?
Yep.
Or let me take these two, short S and long L we have. Let us say which are defined at the top here. I want to get the sum of these two. How can I get? So how can I get is like, let me say let me take one more variable long, which is some lng something, like is equal to, I will say I plus yes, right?
Plus yes, yeah.
Yeah, let's say I plus yes. That's it. You have done some operation here, which is nothing but which is nothing but your I, right? Okay, you have to make it static anyways. I'll explain you what is static, why it is giving continuous static, right? Because in real time you will not be using much of static, but yeah. So here we have got your I plus s. Now let me print out how to print this out, right? So this is a long, but I want to convert it into string, because this is not a string, right? But you can print only string values. So that's why we just have to print something called long dot toString, which I am converting a long into toString. So that is what it is. So let me, and again here this is a main trigger point, right? Here I have my method written here, but I am not calling this method from trigger. So that's why it won't work. So that's why what I'll do, I'll skip this or I'll comment this out. Let us understand what is commenting here, and I'll call this here. So are you able to understand what I'm doing, Shiva?
Yeah.
Yeah. I'll just commenting in the sense this statement will never work.
It won't work. It won't work.
Yeah, perfect. Now let's run it. Can you see the sum? We have printed some sum, right? Which is nothing but I plus s, right? It gave us some sum. So that, which means I've written one more method here and I am calling it up. In the same way you can call any number of methods. Again, let us do something else here. Let me remove this. I am calling this method. Inside this method I am calling this method. Fine. Print sum.
Okay.
And I am calling inside this, I am calling add number. Right? Let us see what happens here. Can you see this? So whatever we printed here, it got printed, and again it went to the next add number here. Fine, long. And let me give some understandable here. Add number result. Let me give some so that you can differentiate between first one and second, right? Let me run this up. Now, can you see? So when it comes to main, it printed something called print sum. It just went to print sum. It printed two things, which is value of your double, which is 120.0, and value of float, which is this. And again I call this. It went to this method. Again it printed this. So that's how we actually call one method inside another method. Fine.
Okay. Yeah.
So there is one more thing, and you can use data types in this way. Like I have used something called long to sum up a short and long, right? So you can use different things in here. Fine.
Okay,
so these are nothing but
you're just trying to. So you're trying to just print some variable values, and then you also at the same time you want to add some numbers at the same time. Right?
Exactly. I'm doing some operation. Yeah.
So
yeah.
Okay. So when you're doing method inside method, it's gonna do two things at the same time, right?
Exactly. No, not at the same time. This sentence is not correct. Same time. What it will do is it will first complete this and then it will go to this.
First one after one. Yeah.
Exactly, one after one. Perfect. Because everything is being done in sequence. It will go to main. It will go to print sum. Now print sum is here. Go here. Complete this first. Complete this, and then and then go to add number and complete this. Right. This and come back to this. Come back to here and get out. So that's how it works.
Can we?
Yeah.
One more question.
Sure.
Can you scroll down? Scroll down a little bit.
Yeah, sure.
Okay, so can we write this method under this method here?
Okay, you mean you want this method under this, right?
Yeah.
Yeah, you can do that. You can write anything anywhere. Yeah, under this one, and
it will first add the values.
No. Again, it will call the same method, and inside this method you are calling this, right? So that's how. So wherever you write method, it doesn't matter at all. It all depends on where you are calling it.
Okay.
Okay. Let me run this up. That was a nice, good question. Let me clear it up and let me run this. Can you see? Output won't change. because my main method I'm calling from here. Now let me show you how actually execution works. Let me debug this, right? I'll put a debug point here. Debugging is nothing but you can see actual running. So can you see this bug debug?
Yeah.
We have used something for this to run, right? Let me debug. In debug you can actually see how the how JVM works here. Let me show you something. Now it went to some other screen now. Wait a minute, I'll just show you. Now can you see a green line been appearing here?
Yeah.
Which means your compilation is here now. So parallelly let us see the console. Now console is clean now, right? Now let me press something called F6 here. F6 in the sense I am moving to this function F6. Can you see where it came? Oops, it went one second, it went down. So let me do one thing. Let me create some more debug points. Debug points in the sense I have one debug point here, I have one more debug point here, and I have one debug point here, let us say, and one debug point here. Just debugging points.
Okay.
Let me run this now. Right. Now let us see what happens here. Now I am in print sum, right? Now let's move on. Can you see it went to print sum? What I am doing, I am taking this. So now my double, it went to some line this. So now can you see this? My console is empty now, right? So here I am trying to do some operation. Let me press F6 again. Can you see this? We printed something here, which is value. Now it went to next statement here, which is float. Let me print this. It printed. See, and then it is I am calling add number. And then it will go to add number. Can you see this? It went to add number, right? Where I am taking two longs and I am adding it up. Press F6. It went to this statement again. Now what it is doing, it is adding result. It is printing. It printed. See, and it came to end. And this end actually I have called this function from print sum, right? So where should it come? It should come to end of this, right? Because this method will call here. Can you see this? It came here again. It completed my method call, right? It went and completed everything, and it came back to this method. Am I right? Because I am calling this method inside this now, and print sum I am calling inside some main. So it should come to this. Fine, and it will go out.
Okay.
So this is how it works. Now your values are printed. Now you understood, wherever you write your method, it doesn't matter at all. What matters is from where you are calling. That matters at all.
In some, okay. So you just have to call that function, and then that is how it starts.
Yes, perfect.
Print sum. So I know that we haven't got into the details of print sum and everything, right?
Yeah.
So can you just give me what print sum means, right?
Okay.
What does that mean?
Print sum is a method where I am doing some operation. In the sense, print sum is some method name. I can also say print sum 1 2 3 or print sum values. I can give any name, but I just have to make sure I'm calling the same method. So print sum is nothing but the method name, right? This is a method, and the name of this method is method name here. So I'm calling print sum values here. The name I'm giving here, right? Where I'm doing some operation called taking a double, printing them, and inside print sum, once everything is done, I want to call add number. That's why I'm calling add number. Add number is again a separate method, and I can also say add numbers. I can say any number. Add numbers for sum. I can say any. This can be anything. This is not predefined. You can give any name here. Fine. I'm just calling this method name from here. It will go to this number, this method, and it will do the operation whatever is there. Okay. So that is how
I have another question.
Yeah, sure.
Okay, so let me just click here. Scroll up.
Okay. So on scroll up. Let me go back to Java. Yeah.
Okay, so let's say I'm going to call this thing to add first. Can I do that?
You can do
like
that.
Let's say I can put here add some values.
Yeah, sure, I understood what you are saying.
So
You want to print
so
this
it
here.
will actually, yeah,
Yeah.
yeah.
And you want to skip
And
this
then-
from here, right? And you want to do this from
Yeah.
here, right?
Yeah.
You can do this.
So it's gonna add first, and then it will print the value, right?
Perfect. It will just add first
Right.
and then go. Yeah. Let me run this up. Right. It will add first.
Yeah.
Right. And it will then go to this. So that is nothing but a method.
So
Yeah.
exactly, I should say, like before whatever is it's declared before the trigger point, that is what's gonna print first, right?
Exactly. Yes. Whatever you're calling from trigger, that is the main method will be called. Right.
Maybe in later we get in depth of how the order goes, right?
Yeah. We'll be going in depth because these are simple declaration of methods and all. You'll be seeing much bigger ones, right? And we'll be using this mains and different classes across the classes. You'll be seeing. You don't have to remember all these things because you'll be getting much bigger ones. Then you'll understand. Then at that time we'll feel these declaration as very small declarations, right? But these are
It's gonna be complicated, I guess, right?
not complicated, but I can say the concept will grow a bit bigger. That's it. It won't be complex, right? So that's how it works, right? Okay, Shiva. Then let's wind up here. I'll send you this recording. You can just go through this recording because again I have a session at 7:30. I have to go out. I have some offline session daily, right?
Okay, no problem.
Let me just